In 2011, Apple introduced iMessage. This is a new app that transfers information using internet instead of SMS. But with the convenience, it also gave users a lot of troubles. This is Grandpa Zheng, and he is enjoying his video on the YouTube. But meanwhile, he finds a new message on his phone. This is the message that Grandpa Zheng has received. Grandpa Zheng thinks that the sender did not type in his information correctly, so he decides to type everything on this website, including his name, the address, and his phone number. A few minutes later, Grandpa Zheng was asked for his credit card information. So he follows the instruction, types in everything, including the card number, the CVV number, and the expiry date, and he thinks everything is done. While Grandpa Zheng is still enjoying his YouTube video, something he cannot understand has happened. It seems that he has purchased some bitcoins, but he doesn't know about Bitcoin at all. Grandpa Zheng wants to contact with the bank, but it seems that his phone now has some other issues. He keeps receiving some junk messages.
Oh my god, why there's so many trash messages? It's so annoying. Oh god. Can someone help me?
So what can we do to help the grandpa in the video? So basically, I think this kind of fraud event is very common in our daily life, and most of people receive that kind of drunk message. So actually, there's a lot of techniques that we can offer to help to detect this kind of fraud and drop that message. And the snort is one of the most successful technique among them. And so we will just to introduce what a snort is and how we improve it. So snort is basically an open source network intrusion detection and prevention system. So it is actually widely used for monitoring and analyzing network traffic in real time to detect and prevent malicious activities such as attacks and probes. So yeah, so actually in our daily life, this technique has already been widely used. There's a lot of companies that we all know that we can name it Walmart, Amazon, Microsoft, Apple, Chevron, Costco. All the info is come from zoominform.com, and it can those giant companies from all industries are right now using Snort to help their security network security, and it can demonstrate that it is really a valuable technique. And Snort is actually a technique that can have a giant commercial value, and there's a lot of companies that are right now to develop Snort to make money, and the SourceFire is one of the most successful one among them, and it is a company that focused on Snort developing, and it is founded at 2001 by Martin Roach and the person in the picture. And just 6 years later, this company went to IPO, went to the public market, and it just spent another 6 years. It had been acquired by Cisco, the network giant, for 2.55 billion, which is a huge amount back to that time. And I can bet that if it is acquired at right now, it might be double. The amount will be double. So, however, we all know that Snort is a technique to help with network security, mainly focus on software technique. But in the past 10 years, the bandwidth of our network is growing rapidly, and we can see from those two tables, it shows that the global average internet speed has been increased rapidly, and according to the table right here, it's predicted that it will be reach among 1 gigabit per second at 2013. It's just 5 years later. And another table is people who are using the network all over the world. We can see that from the 2011 to 2022, back to 2011, just 32.7% people all over the world are using network. But right now, it has reached 69.0%, and it's a data 2 years before. So I think the data has already reached more than 70%. So in conclusion, that with the growing of our network, it means that we can transfer data between different nodes of different user much more faster, much faster, and more data means that there will contain more fraud threat. And if we only use purely software snort, in that case, our snort cannot handle that big amount fraud message. So in conclusion, that purely software snort is just too slow right now. We really need to give a method to improve the speed by using hardware.
So here is our hardware design. So we use a boom filter as our hardware acceleration to accelerate the the network processing. So we also have a dual CPU with each CPU has 4 threads. So for example, like the story tells, the grandpa has a span always starts as / USPS. So this will be our signature, and this pattern will be set to our boom filter. So first it will convert to a hexadecimal, which is 2F2F75737073. So it will be set to the boom filter. So in the boom filter, when the pattern has entered, it will go into a hash functions. So there are 3 hash functions for the for the pattern, and each will enable one entry of the table and make the all initial 0 table to be 1. Like here, it will renew the table like 3, 127, and 253 got higher to 1. And then when real packet arrives, the headers will first go into the boom filter and pass to the CPUs. And like the pattern we set it has arrived, it will first go into the boom filter. So in the boom filter, it will go into the same hash functions and it will have the same result with the preset pattern. So like the red ones, it's all matched. Since boom filter have the possibility of fake matching, so the packet will continue goes to our CPU2. In CPU2, it will check the pattern with the software. So all packet has two parts. The first part, one of the part is the control part, and another part is the data part. So the packet will store into the two memories. One is the control memory, the other is the data memory. So in the data memory, it will go through the pattern and check if it is matched, and we set with the software we set it's matched, so the packet will get dropped. For example, if another packet does not match with the set pattern, so showing the boom filter, it will first go into the hash functions, and it will renew the table, but with different pull ups. So like the entry 1, entry 128, and entry 255 got enabled, and it does not match with the pattern preset. So it will go into the CPU1. So in CPU1, it will check the data memory. So if it has a small length or it has a very big a massive match, like it's all same pattern, it will determine it as a DOS attraction. And in this case, the packet will get dropped. But here we have a good packet, so it will directly go to the output queues and send to the user. So we can see the improvement. The first part is with the acceleration. It has a 1.75 megabits per second bandwidth, and the bottom one is the software purely. It only has a 1.05 megabits per second, so it's about like 67% improvement. But in real life, since we are only using the Express PCI, the transmission rate could be limited, but in real life, the improvement will be more dramatic. So this is the demonstration of hardware. So first we have already download our bit file on the board, and then we need to set the boom filter pattern. So we decide to use the txt file as our suspicious packets. So in a normal packet, it does not contain a spam signature, but in the spam sig txt, it will include a spam signature, which we just for demonstration, we use ABCDFG as our spam signature. So as you can see here, this will be our spam signature. So let's first set the signature. So we have already set the signature, and then we try to send the packet to from node 3 to node 0. So we set node 0 to client, and this will be our sender. Yeah, it is now successfully sent the packet. And then we try to send the spam packet. So it will get dropped. And let's try if we move the signature to other location. Yeah, and delete the with other pattern. We send it again. It still got dropped, which means that our Boom filter can successfully identify the pattern, and can be successfully drop the packet. Now we test the DOS detection demonstration. So like we will send a empty packet, like very small empty packet, to simulate the DOS. So if it contains a lot of same thing or empty, it will get dropped. Let's first test with the detection mode. So I have a 10 megabit packet. So let's send it to from node 3 to node 3 to node 0. You can see it should be denied. Yeah, it will get denied, so it will avoid the detection. And now let's use Bible as a normal file, a big normal file, and send to the from node 3 to node 0. You can see it can successfully send to the direction. So it demonstrates that our DOS can successfully work.
So in order to compare the performance of three kind of methods, we actually use the bandwidth as the index, and we have three kind of method to in our experiments. So in order to detect junk message, the first one is purely software. So we basically use one self-defined RISC-V processor. We insert some kind of code instruction to the instruction memory, and we run the instruction to detect the junk message, to detect the pattern. If there is a pattern match, we drop the whole package. And for the second one is the IDS, mini IDS, which is a preview offered by the course, and we just briefly use it as a comparison, to compare the performance. And the third one is Bloom filter. Bloom filter is kind of advanced IDS. It can handle with multiple patterns at the same time and has a higher throughput. So in our experiment, we mainly just download three kind of bit file to the NetAVGA, and we use that method. We send 10 different text files between the nodes, and we capture the bandwidth number and memorize it and get the average number for that method. So from the table, we can see that the average bandwidth for the purely software is 1.05, and for the IDS, mini IDS is 1.43, and the Bloom filter is 1.0. 75, or the unit is megabits per second. So we can see that from the comparing to the purely software method, so IDS can bring 66% improvement, and the Bloom filter can bring 67% improvement. And comparing to the IDS, Bloom filter will run 22% faster than the IDS. So in conclusion, that our hardware accelerator can increase the bandwidth with higher throughput, and comparing to the IDS, which can only handle one pattern at the same time, our Bloom filter can even handle multiple patterns at the same time with even higher bandwidth. So I think our design is valuable.